All right, so first new thing for you this semester, I think, and I don't think you've seen this before, is we're going to start talking about the other methods for solving systems. The first other method is going to be substitution, and this is going to look a little weird at first. Okay, so you're going to have to sort of bear with me and hang in there and keep trying these, all right? But we want to talk about this because graphing is not a good way to solve a system. There's too much inaccuracy. Unless your solution is going to be a nice, pretty whole numbers, then it's going to be hard to tell what the solution actually is. So there's a lot of issues with the graphing method. So we want to talk about this substitution method. And so by the time we're done here, we need to understand how to solve, and this objective here is a little bit longer than what we're going to worry about today. We're just going to worry about solving pairs of linear equations by substitution, not by graphing or elimination, okay? Anyway, let's move on. Let's think about what happens when we substitute, right? For example, in this first guy here, we want to find y if x is equal to 7. Okay, well, if we know that x is equal to 7, then I'm going to take 7 and I'm going to literally plug it in for x, right? I mean, we know that. I'm going to literally take that x out and put a 7 in its place. So I get 3 times 7 plus 2y equals 23. Of course, 3 times 7 is 21. Subtract 21 from both sides. Divide by 2. And y equals 1. Okay? Simple as that. Same thing over here. If x is 7, I'm going to literally take this x out of the equation and put 7 in its place. So I get negative 5y minus 3 times 7 equals 4. So we get negative 5y minus 21 equals 4. Now I'm going to add 21 to both sides, divide by negative 5, and so y is negative 5. Okay? So that's what we do when we substitute. If we know what x equals, then we can plug that in for x. You know, on the flip side, if we know what y equals, then we can plug that in for y anywhere we want to. Okay? It doesn't have to be any different if we're I just did that. If we're not plugging in numbers, if we're plugging in expressions, it's going to be the same idea. Okay? So for example, this first guy, y equals 3x and x plus y equals negative 32. Those are two, it's a system of linear equations, and we're going to solve it by substitution. Now the only way we can substitute for x or for y, and we can substitute for either one, is if we know what x equals or if we know what y equals. So my first question when I approach a problem like this is, do I know what x equals? And right now, I don't know what x equals. I don't have an x equals something. Do I know what y equals? Yes, I do. This guy right here tells me that y equals 3x. That means that anywhere I see a y, I can plug in this 3x. Say, for example, right here. So I'm going to literally take this y out and put a 3x in its place. Right? X plus 3x is 4x. Now we're just solving like it's a normal equation. Divide by 4 and x equals negative 8. Now I know what x equals, and you have to remember that when we're looking for a solution to a system, we're looking for an ordered pair that satisfies both equations. And right now I only have the first half of the ordered pair. I need to know the numerical value for y. Now I know that y equals 3x, but I need to know what number y equals. So since I know that x is equal to negative 8, I can literally come up here and plug in negative 8 for x in that equation. So I would get y equals, I'm going to literally take the x out and plug in and put in the negative 8. So I get negative 24. So I think the solution is negative 8 comma negative 24. Okay? Why do I say I think that's the solution? Well, because I don't know for sure. But how can I find out for sure? Well, I can just plug that point in I can substitute that point in for x and y in my two equations and make sure that it's true. I'm going to do it for this first one, but since we're focusing on the substitution method of solving, I'm not going to do this for all of them. You should, okay? So for the first equation, I plug in negative 24, and I plug in negative 8 for x. So I get negative 24 equals negative 24. It works for that guy. Now I'm going to plug in negative 8 for x. I'm going to substitute negative 24 in for y, so I get minus 24 equals negative 32. Combine those, and you get negative 32 equals negative 32. And there you go. That works as well. So I know that negative 8 comma negative 24 is the solution. Make sure you're checking your answers. Okay? All right. Now, same thing. Going to keep asking myself, to solve this, and I guess we need to talk a little bit about why we're substituting in, right? Why are we substituting? Well, the problem is I can't solve that equation in that box by itself. It's got two variables in it, right? I can't solve one equation if it's got two variables in it. So what we can do is if I know what x equals, which I do up here, then I can plug in what I know x to be. And hopefully that will reduce the number of variables we have down to 1 so that I can actually solve it. Okay? So, do I know what x equals? Yes. I know that x equals negative 4y. So I'm going to literally plug that in, substitute that in for the x right there. So I'm going to literally take that x out and put the negative 4y in its place. And make sure that I multiply the 2 and the negative 4y. Right, so I get negative 8y minus 3y equals negative 11. I get negative 11y equals negative 11. Divide both sides by negative 11 and y equals 1, which is fantastic. But again, I'm looking for an ordered pair here. So y is 1. I need to find out what numerical value x has. So I'm going to plug it in. And I'm going to be strategic about this. I'm going to be smart about this. I'm going to plug y in for where it makes the most sense. I'm going to substitute it in for the y here because x is already by itself. I don't have to do a lot of algebra after I substitute the 1 in. So I get x equals negative 4 times 1. And so x is equal to negative 4. So my solution is negative 4 comma 1. Now stop and remind yourself what that means. If that's the solution to this system, that means if I plug those two numbers in for x and y in my two equations, it should make those two equations true. It also means if I graphed those two equations, those two lines, those two graphs, those two lines should cross and meet at negative 4 comma 1. Okay? All right. Now you try. Try this guy. See what you come up with. Stop the video and then start it again so you can check your answers. Okay? This is what you should have come up with. 0 comma negative 7. Okay? Since we know what y equals, we're going to literally plug this negative 3x minus 7 in for y. So I'm going to take this y out and put the negative 3x minus 7 in its place. And so we should get this. Now, make sure you pay attention to this part. Now, we have to multiply the negative 3 times all of what we're plugging in for y. So I got to distribute, right? That's where you get the plus 9x and the plus 21. Make sure that you distribute that negative 3. And the rest is just your normal algebra. Okay, hopefully you got there. If not, hopefully you can stop the video here, check your work versus this work, and learn from your mistake. All right? All right, moving on. Number 4. Okay? And number 4, your example here may be done for you already, but I'm going to walk you through it real quick. So I'm going to ask myself, do I know what x equals so I can plug in x somewhere? And the answer is no. I don't know what x equals. Do I know what y equals? Again, the answer to that question is no, I don't. So I need to figure that out. I need to get one of these two equations. I need to take one of these two equations and solve it for one of the two variables. And it doesn't matter. If you go back and look, in number 1, we substituted in for y. In number 2, we substituted in for x. In number 3, we substituted in for y. So it doesn't matter if we solve for x or if we solve for y. But let's be smart about this. Work smarter, not harder, right? Look at your two equations. Which equation would be the easiest to solve for which variable? And without knowing a lot about what you're looking for, hopefully you're looking at this and saying, well, I think it's going to be easier to get this y by itself, to solve for that y. And the reason why it's going to be easier is because it doesn't have a coefficient, or at least the coefficient is 1. And so that means we're not going to have to divide by anything, which means I'm not going to get a fraction when I'm solving for that variable. So I want to use this second equation, and I want to get y by itself. And I'm going to do that by adding 2x to both sides. So y is equal to 2x minus 3. Now I know what y equals. So I can plug y back into anything I want to. I can substitute 2x minus 3 in for any y I want to. Now, I could plug it in, I could substitute in for this one. But if you do, you're just going to get 0 equals 0, and it's not going to help you find x. So I don't want to do that. I want to take this, and I want to plug it in for, I want to substitute it in for that x. Sorry, not that x. I want to plug it in for this y right here. We're substituting in for y. So we get 3 times 2x minus 3 plus 4x equals 14. Distribute, distribute. So we get 6x minus 9 plus 4x equals 14. Combine like terms, you get 10x minus 9. 10x minus 9 equals 14. Add 9 to both sides, 10x equals 23. Divide by 10, and x is equal to 23 over 10. Oh no, we got a fraction. It's okay, fractions are numbers too. They're allowed in math class. Okay? We're still going to have to go find out what the y value is. So right now we have an ordered pair. We have half of an ordered pair. That is the solution to this system. I'm going to be strategic about this again. I'm going to plug this value, I'm going to substitute this value in for x where it makes the most sense, and that is right there. Okay, because y is already by itself. I don't have to do a lot of algebra. So y is equal to 2 times 23 over 10 minus 3. Now you're going to have to work with some fractions. You're going to have to get good at working with fractions. If I multiply 2 times 23 over 10, then I can cross-reduce, make this a 1 and a 5. Multiply straight across. 23 times 1 is 23. 5 times 1 is 5, minus 3. Now, I can't subtract those two until they have common denominators. This denominator is a 1. The common denominator is 5. So multiply this by 5 and this by 5. So now I get 23 over 5 minus 15 over 5, where I'm just going to subtract the numerator, and I get 15 over 5. So I'm going to get 8 over 5. And you can't see that for the add, but it's 8 over 5. Okay, that's the solution. Now, yes, you should plug that back into both equations and make sure that it makes sense. And make sure that it gives you something that's true to check your answer. Okay? Now, I do want you to stop and look for a second. What does that mean for this point to be the solution? And what that means is, if I were to graph those two lines, they would cross at that point. Well, 23 over 10 and 8 over 5 they're not whole numbers. So when these two graphs cross, they're not going to cross at a street corner. They're not going to cross at a very pretty place. They're going to cross somewhere inside of those little boxes on the grids. And so you wouldn't be able to tell 23 over 10 and 8 over 5. So hence the reason why we have this substitution method, and it's a little bit more accurate. Okay? All right, but the bottom line is this. You got to take one of the equations and get one of the variables by itself, and then start your substitution process. Okay? All right, here's another one. Okay, and I'll get you started by asking you this. You don't know what x equals, don't know what y equals, so which equation and which variable do you want to solve for? Which one's going to be the easiest? And remember, you can solve for y or you can solve for x. It doesn't matter. Okay, I think it's just going to be easier to take the first equation and solve for y. So take the first equation, get y by itself, then start your substitution process. Stop the video, start it back up when you're done, and check your answer. Okay, did you get this? Take the second equation, take the first equation, subtract 2x from both sides to get y by itself, and you get y equals negative 2x plus 1. So we're going to take this negative 2x plus 1 and plug it in for this y right here. And when we do the math, we do the arithmetic, and you should get down to x equals negative 3. Now that we know that x is negative 3, we plug it back in over here to find the value for y. Okay? You can stop the video here, take time to look through what you did versus what I've done, and see if you can figure out where you went wrong if you missed it. Okay? All right, otherwise, we'll move on. Here's another one. I'll give you a few minutes to give this a shot. So stop the video, try to figure it out, and then start it back up again and see if you're right. This is what you should have gotten. You should have gotten 1 comma negative 1. Here's the work. So again, stop the video, compare what's on here versus what you got if you missed it, and see if you can't figure out why not. If you're not able to figure it out, or you're still struggling to get through this, come see me during STAR or after school, and we'll work through it some more. Okay? All right. Infinitely many solutions or no solutions. We know from the graphing method that systems might have infinitely many solutions or no solution. How can you tell? Okay? Well, let's go through our substitution process and see if we don't recognize what's going on. All right, so do we know what x equals? Yes, we know that x equals negative 2y plus 4. So I'm going to literally plug that in for this x. So I get 3.5 times negative 2y plus 4 plus 7y equals 14. Now, distribute. We get negative 7y plus 14 plus 7y equals 14. Combine like terms, these are going to add out to 0. And so you just get 14 equals 14. Now let me ask you something. Does 14 equal 14? Does 14 always equal 14? Yeah. So then what's your solution? It's infinitely many solutions. Okay? Just like before when we were solving our equations. All right? Now think about what that means. Infinitely many solutions means that if we were to graph these two lines, create these two graphs, the two lines would just be the same line. Right? So the equations really are exactly the same. They just look a little different. All right? All right. Try another one here. See what you get when you start doing your substitution process here. And then see if you can't figure out what that means as far as the solution is. And then start the video again and see if you're right. Okay? Did you get this? So if we substitute the 3x minus 11 in for the y, literally take the y out and put the 3x minus 11 in its place. Then when we do our algebra, distribute the 2, combine like terms, we get negative 22 equals 12. And we know that's not true. It's not ever going to be true. So this is a situation where you're going to get no solution. Okay? Now think about what that means. No solution. If we were to graph those two equations, what would give us no solution? Well, two parallel lines. Right? So they're going to have the same slope, different y-intercept. All right? All right, got one more here. So try number 9. Again, stop the video, then you can start it back up and check your answer. And there you go. Did you get no solution? Hopefully you did. Okay, again, if you're still not able to work through this or you still have some questions, come see me and let's get this thing ironed out. All right? The story problems we'll wait on for next time. We're going to spend another day on substitution, so there should be plenty of practice. Okay?